Hello, welcome students to week 3 optical instruments. This is your tutorial help video for week 3. Now in week 3 you have learnt about nearsighted, far-sighted, near point and far point of nearsighted and far-sighted people. Okay. You have also looked at different optical instruments. Okay. Now this optical instrument is what we call the eye. Okay, so our eye is a very sophisticated optical instrument that is able to produce images of objects we see. Okay, other optical instrument is a simple magnifier. Okay, it says the angular magnification at maximum when the image is formed by the lens is given by this formula. So maximum magnification is equal to 1 plus 25 over the focal length of the simple magnifier. And for the simple magnifier, when you have a relaxed eye, the magnification is given as 25 over the focal length. Okay, next we look at the microscope, the compound microscope. For the microscope, there's two magnifications because you know the microscope has two lenses, one at the eyepiece and the other one what we call the objective lens. Okay. So the magnification of the objective lens is given by this formula. The lateral magnification, it's minus q over p, which is approximately equal to the length of the microscope divided by the focal length of the objective lens. The angular magnification of the eyepiece is equal to 25 divided by the focal length of the eyepiece. And then you get a overall magnification which is equal to the lateral magnification multiplied by the magnification of the eyepiece. You multiply the two together, you get the total magnification of your microscope. You also have astronomical telescopes, and again the magnification of the telescope is given by f0, which is the focal length of the objective divided by the focal length of the eyepiece. Okay. The length of the microscope will be equal to f0 plus f. Okay. Looking at some examples. Okay. The first question, it says an individual is nearsighted. His near point is 13 centimeters and his far point is 50 centimeters. Okay, nearsighted means people cannot see far away. What lens power is needed to correct his nearsightedness? Okay, so we have to find what is the power of the lens that is needed to correct this person's nearsightedness. Now what we know is that his far point is 50 centimeter. Okay, so to correct that, what it means is that the lens should produce an image. The lens should produce an image at 50 centimeters in front of the person. So since it is produced on the same side as the object or in front of the lens, it is minus 50 centimeters. Okay, so usually we say that the objects for far point is when we are able to see objects which are infinitely far away. So our objects can be at an infinite distance, but the image of that object has to be produced at 50 centimeters for us to actually see it properly. Okay. And using this we find what is the focal length that is needed. So we know that 1 over f using our length equation is equal to 1 over p plus 1 over q. So this becomes 1 over infinity plus 1 over minus 50. So you'll see 1 over f is equal to 1 over minus 50. F or the focal length is equal to minus 50 centimeters. Okay. So the focal length of that lens is equal to minus 50 centimeters. But the question is asking what is the lens power? To find the power, we know that power is equal to 1 over f, okay, and f has to be in meters. Our focal length has to be in meters. So we found out that the focal length is equal to minus 50 centimeters, which becomes minus 0.5 meters. So our power is equal to 1 divided by minus 0.5. So you get a power of minus 2, and the unit is diopters. And this is what, whenever you go to have specs made, this is what is given as the power of your lens. Okay, part B, it says when the lenses are in use, what is this person's near point? So that means his near point is 13 centimeters, and when he's using the lens, the image needs to be produced at 13 centimeters. Okay, so anything you're looking at, the image of that object has to be produced at 13 centimeters. Again, since it is in front of the mirror, it will be minus 13 centimeters. Okay, we already know that the focal length is minus 50 centimeters. So we need to find how close we can bring an object to the person's eyes for him to see it properly. Okay. So we are actually trying to find how close we are able to bring the object. Okay. So again, if we use that formula, we'll see that 1 over p will be equal to 1 over f minus 1 over q. So we get 1 over minus 50 minus 1 over minus 13, and if you do that, okay, you'll get 87 over 650, and then you'll see that p will be equal to 650 over 37, which is approximately equal to 17.6 centimeters. What this 17.6 centimeters means is, if you want to look at close object, this person can bring the object only as close as 17.6 centimeters away from his eyes. If he brings the object any closer, then the image of that object will become blurry. Okay, this is an interesting question. It says the length of a microscope tube is 15 centimeters. The focal length of the objective is 1 centimeter, and the focal length of the eyepiece is 2.5 centimeters. What is the magnification of the microscope, assuming it is adjusted so that the eye is relaxed? Now the important thing here is this word which says the eye is relaxed. For the eye to be relaxed, that means that the image formed at the eyepiece must be at infinity. Okay, so whatever the person sees at the eyepiece, it must be at infinity. Now the things which are given is, it says, okay, we have the eyepiece which has a focal length of 2.5 centimeters. Okay, so there must be some object here, and this is the objective lens, which is 1 centimeter. Okay, now the length of this tube is 15 centimeters. Now what we do is, when we solve this, we are trying to find what is the magnification of this microscope. So we know that the lateral magnification of the microscope is given by minus Q over P. Okay, and the magnification of the eyepiece is equal to 25 over FE. Okay, now before we can actually find the magnification of the objective lens, we need to find out where the image and the object is for that objective lens. Okay, so basically what happens is, whatever is the image of the objective lens is the object of the eyepiece. Okay, and whatever is the image of the eyepiece, that is what we see. And because it says that the eye is relaxed, we say that the image of the eyepiece must be at infinity. Okay, so when we do this, when we try to find where the object of the eyepiece is, we try and find where the object of the eyepiece is. What we do is again use the formula. So we use 1 over P is equal to 1 over F minus 1 over Q, and since Q is infinity, it is equal to 1 over 2.5 minus 1 over infinity. So you'll see that the object of the eyepiece is at 2.5 centimeters from the eyepiece lens. Okay, so from the eyepiece lens, somewhere here, 2.5 centimeters, that's where the object is. So once we find that the object is at 2.5 centimeters from the eyepiece, what we do next is we try to find where the object of the objective lens is. Okay, and to do that, what we do is again use the mirror equation. Okay, and like I said, the image of the objective lens is equal to the object of the eyepiece. So that means the image that is produced here, that is what we look in the eyepiece to see the final result. Okay, so now from this objective lens, how far away is that image? So we need to find that, and by looking at that, we can see that our QL, which is the object, which is the image of the objective lens, is equal to the length of the tube minus the 2.5, or the distance of the object for the eyepiece. Okay, so what we get is 15 minus 2.5, we get 12.5 centimeters. Okay, once you get Q, which is 12.5 centimeters, next what we do is we try and find what is PL equal to. Okay, to do that, we use the mirror equation. Okay, so we know QL is equal to 12.5 centimeters. Our PL will be equal to 1 over F minus 1 over Q, which is equal to 1 over 1 minus 1 over 12.5. Okay, and you'll see that your P comes to 1.09 centimeters. Okay, so after you have found the P here, which is 1.09 centimeters, and we have found the QL, which is 12.5. Okay, the next step is to now find the magnification of each. Okay, and the magnification is equal to, we know that it is equal to M, the objective magnification, multiplied by the magnification of the eyepiece, which is equal to minus QL divided by P multiplied by 25 over FE. So once we put the values in, we get minus 12.5 divided by 1.09 multiplied by 25 over 2.5. Okay, so our final answer comes to minus 150. So but that is by how much the image will be magnified. So thank you very much for your attention, and hope this video helps you to solve your tutorial questions. Thank you.